Let's take a look at the questions on homework 13. The first one is a review of the type of functions and their shapes. Remember, the quadratics are shaped like U's. The absolute value functions are shaped like V's. And the exponential functions are shaped like a soft J curve. The square root functions have a limit, right? And they extend in one direction. And these sideways curvy ones, if they're going from left to right, are cube roots. If they're going up or down, they're cubic. Let's take a look at the correlation coefficient. The correlation coefficient tells you the relationship to these scattered dots to what the line of best fit would be. So I can see that these are pretty loosely scattered, but they're definitely negative. They're definitely moving in a downward trajectory. So that's a weak negative. This one seems equally dispersed up and down and left and right. So no correlation. And this one is perfectly straight, but it's negative, so it's a perfect negative correlation. Again, this one seems equally dispersed, so I'm going to say no correlation. Same here. Now this one's going to ask you to look at your correlation coefficients down here, or your R values. Which of the following regressions is a strong positive? So regression 1 is out because it's negative. So 2, 3, and 4 are positive, but this one is over the number 1, which is not possible. So we're going to go with regression 2 because 0.67 is higher than 0.12. Again, we're looking for a weak linear relationship, and it doesn't say whether it's positive or negative, but it needs to be weak, so that's going to be the lowest number we have here, which is regression 3. Strongest positive linear, so again, 2 is out. 1 is out because it's above the number 1, and regression 4 would be higher. Let's take a look at the scatter plots. The trend of the data is downward, so it's negative, and I would say this one up here is an outlier, and that the pattern is decreasing as x increases. Yep. This one seems to be pretty equally dispersed, so I'm going to go with there's no correlation here because they generally show no pattern. This one is slightly decreasing, but it is definitely decreasing. So I'm going to go with negative linear because there's no one yellow dot that's far away. Decreasing as we read from left to right. Ooh. This one seems to go up and then down. So I'm going to say that this is non-linear. And that's because it follows a curved pattern. Follows a curved pattern. Now let's interpret this line of best fit. I need to read the labels carefully here. And the scatter plot shows a line of best fit from 7 people's femur. That's your leg bone, right in the big part of your thigh. And it also shows their height. So the larger your femur, the higher your height. So what is the meaning of the y value when x is 50? Well, if x was 50, it would be right about here. And that means that the y value would mean that your height was around 167 centimeters. So an expected height of 168.4. Yeah, that's possible. Yep. An expected height of 50? No. Height of an actual person? No, because it's a predicted line. So all of these ones with actual are not true because they're talking about the line. The line is a prediction. The line is a prediction. All right, this next one shows the catfish length to the catfish weight. So the longer the catfish, the higher it weighs. So they're asking specifically what this point here, represented in green, what it would represent. So the 45 is the x value, or the catfish length. So a catfish of 45 inches would have a weight of 71 pounds. Caught a catfish of 45 inches weighs 71 pounds. That's the actual data point, not the line of prediction. So we're looking for something that says actual, not expected. So if he catches a 45-inch long catfish, it'll weigh 71.4 pounds. She is keeping track of the time and the people inside the music hall. So we're looking to see when x is 0, right here, the time at 6 p.m. What does the slope of the line represent? All right, so if the 0 is 6 p.m., then it's going up a quarter of an hour, or 15 minutes. Every increment is 15 minutes past 6. And the people inside is increasing 10. So it's about 10 every 15 minutes. So is it the average change in the number of hours since 6 p.m. for every additional person? No, it's every additional 15 minutes. The number of hours past 6 p.m. where there's one person in the music hall, the number of people in the music hall 1 hour, or the average rate of change in the number of people over time. So they're asking what the slope represents. And if you remember correctly, when you hear the word slope, this image should come to mind. And when we go look at our labels, people, time. So the slope is people over time. So the average rate of the number of people over time, this choice here is the slope. All right, linear regressions, you're going to need your graphing calculator for this. So you could certainly turn your calculator on so you can get some good practice. Stat, calc, edit. So you're going to enter these numbers into list 1 and these numbers into list 2. And when you go back to stat, calculate linear regression number 4, and it's telling me the slope is 10 and the y-intercept is 88. Using this equation, round to the nearest hundredth. So that would be y equals 10.00 plus 88.00. And then it asks us, using this equation, find the projected profit for 2016. Well, we started in 2005, so 2016 would be 11 years later. So I'd want to put an 11 in my equation. So 10, instead of an x, we'll put an 11 plus 88. So $198,000. Okay. I guess since it was an integer, you didn't have to put the 0.00, but I recommend it. Now let me show you, if you don't have your own graphing calculator, you could certainly copy these values, open the statistics calculator in another window, paste the values, and use this feature up here. Calc, linear regression. You can turn the diagnostics on. Now here's your data. You'd have to use your tabs to go back and forth between the calculator and the question. So let's see, it says round to nearest hundredth. So it's 18.1 and 104.1. So y equals 18.1x plus 104.1. And then they want us to find the projected profit for 2022. But if we start at 2011, then 2022 is 11 years later. So take your calculator out, type your equation, insert an 11 into your x value. 303.2. It says round to nearest thousands of dollars, and I didn't pay attention. Your final answer is not rounded correctly. Yikes. Be careful. Alright, again, you can use, slide this down. You can use the Delta Math calculator and paste the values, but you want to get good at using your own calculator because that's what you'll use on the Regents exam. The question asks, write an equation round to nearest hundredth. 29.57 x and 64.24. And then it asks us to round to the nearest dollar. 2015 will be 9 years later. So get my calculator out. 29.57. 9 years later. 330. Rounded to the nearest dollar. Alright, last one. Same task. But this time, you're going to calculate exponential regression. That's a nice tight fit, 0.99. So let's see. Round all coefficients to the nearest hundredth. 732.37. Y equals 732.37. Parentheses. 1.20 parentheses shift 6 and a power of x. Determine the number of bacteria after 12 hours. So turn your calculator on. 732.37 parentheses 12 hours raised to 1.20, and the 12 hours is the exponent. 12 hours. Rounded to the nearest whole number. 6529.8 is going to be 6530. And that's that.